Okay, on today's notes, we are dealing with conditional statements and then counterexamples. So first, let's talk about what a conditional statement is. If you'll remember, we talked about that sometimes proofs are written in paragraph form, and we're not going to go into writing those at this point. Maybe at the end of the year, we'll see. But part of what we are going to do is we want to look at how would individual statements be written when we're talking about these math ideas. And so one way we can do that without actually writing tons of different paragraphs or paragraph proofs is we can look at conditional statements. So a conditional statement is going to be a statement that's written using the words if and then. And so when we write a conditional statement, it's always going to say if this, then that. So if it's raining outside, then break would be canceled. Okay, something like that. And so we have names for the parts of those conditional statements. The first part is called the hypothesis. It's the word that comes immediately, or the phrase that comes immediately after the word if. So if it is raining outside, that's the hypothesis. Okay, and then it's going to say then. It's going to tell you what will happen, right, if it's raining outside. That last part is called the conclusion. It comes after the word then. So in our example, that would be, it said then break would be canceled. So break would be canceled is the conclusion. So notice the hypothesis is always the part that comes after the word if. The conclusion is always the part that comes after the word then. Sometimes we write this in like symbolic form, so it'll have a P, okay, and then I'll have an arrow, and it'll say Q, and we read that as if P, then Q, or sometimes they'll say P implies Q. So it's always telling you this is where we're starting, and this is the conclusion you can draw because of that starting place. So now we're going to practice. You have two examples here, okay, and I want you to practice underlining the hypothesis and circling the conclusion. Remember, you can pause the video if you need a couple more minutes to do this. Okay, let's look at the first example. So on this one we have, if you live in Dallas, then you live in Texas. So the hypothesis is you live in Dallas. Okay, the conclusion is you live in Texas. Notice the words if and then did not get circled or underlined because they are not part of the hypothesis and conclusion. They're kind of like the anchor points. They stay put. They don't move. They're going to always stay where they are. Now, notice too, in just a second, we're going to talk about sometimes these statements are true and sometimes they're not. So you could say, if you live in Dallas, then you live in Texas. That could be true or false. Most of us would think, oh yeah, that's true, because we would think of Dallas, Texas. But if there was a Dallas in another state, which I'm feeling like there is, but I don't remember off the top of my head, then you could say that was false, because if there's a Dallas, say in Tennessee, then you could be in Dallas, Tennessee, right, instead of Dallas, Texas. So it's going to be really important to pay attention to whether or not that statement is true all the time. Okay. Let's check the second one. The second one says, if the sum of the measures of two angles is 90 degrees, then they are complementary angles. Okay, so on this one, the sum of the measures of two angles is 90 degrees. That's your hypothesis. They are complementary angles. That's your conclusion. And again, notice the if and the then are not circled and they're not underlined. They are not part of the hypothesis or the conclusion. They're just the anchor points to tell you where the hypothesis and the conclusion are. Okay. And again, you could check that for the truth value of that. And so you would say, okay, if we add two angles together, because sum means add, and they add up to 90 degrees, then yes, they would be complementary angles. Okay. Now, sometimes we switch the hypothesis and conclusion. And this is what we call the converse of a statement, because sometimes we want to know, does this always work? Can I go forwards or backwards on this and get the same result? Okay. So if you switch the hypothesis and the conclusion, right, and you leave the words if and then alone, they stay put, then you would get the converse. So we're going to practice doing some of that. So let's look over here. First we have, it says, an obtuse angle has a measure greater than 90 degrees. So first we have to turn this into an if-then statement. So we would say, if an angle is obtuse, then it has a measure greater than 90 degrees. Notice I had to switch up the words here a little bit to keep the syntax correct, right? Make it good English writing. But we're keeping the order of things the same, like the overall organization the same. So angle, measure greater than 90 degrees, right? So an obtuse angle, this part has to be in the hypothesis. The measure greater than 90 degrees, that has to be in the conclusion, okay? So if an angle is obtuse, then it has a measure greater than 90 degrees. And we would say, is that true or false? Yep, that's true. You could say, and I guess we haven't actually covered them this year, you technically would have like an angle that is a 180 degree angle. That would be a straight angle. If you chose that, then you would say false. But I put true on our notes key because we didn't learn about straight angles. At this point, we haven't talked about those or named them. So I'm just kind of throwing that out there, right, that those exist. Then we want the converse. So we're going to take this first part, the hypothesis, and the conclusion, right, which goes all the way down to here, and we're going to switch those. And when we do, it's going to say, if an angle's measure is greater than 90 degrees, right, if an angle has a measure greater than 90 degrees, then it is an obtuse angle. Okay, notice the if and the then, they stayed put. They didn't move. They're in the same place that they were up on the first one. Only the other words traded places. Okay. And so then again, we could answer true or false. Say true on those. All right, prime numbers only have two factors. So remember, a prime number is a number that has to be divisible by itself and 1, but not be divisible by anything else, no other factors. So first we would write this as an if-then statement. So if a number is a prime number, okay, then it will have only two factors. Okay, and that would be true. Can't have any more than that, like no more factors than that. Okay, and then we want to switch that around for the converse. So if a number is prime, then it only has two factors. So we're going to switch it only has two factors. So if a number has only two factors, then the number is prime. Okay, and then we would also say that that one is true. Keep in mind the converse might be a different truth value than the original conditional statement. Okay, so a counterexample is an example that's used to prove that a statement is false. Notice it's an example, not an explanation. So you have to be really careful on these. And I gave us some harder problems or some harder examples on here so that we could talk through them just a little bit. The truth value is going to be whether or not that statement is true or false. So these up here are truth values that we've been finding. Okay, so if an angle measures 95 degrees, then it is acute. So we would say, is that true or false? On this one, that is false. Okay, and our counterexample would be that like an example of an angle that's 95 degrees. So I drew me a 95 degree angle, I named it, and we would say angle ABC is an obtuse angle. So notice this is a specific example, like it gave us an example and said this is an obtuse angle. I'm not explaining acute angles are angles that are less than 90 but greater than 0 degrees. Like I'm not giving an explanation, it has to be an example. And so you could just give this, I think for our notes, I went ahead and put this on here so that you'd understand what your picture is a counterexample of, or like what kind of example you were giving. Okay. The second one says, if Mrs. D is 5 foot 2 inches tall, then she is 54 inches tall. Well, if I think about that one is also false. Okay. And my counterexample is 5'2" equals 62 inches. Miss D is 62 inches. And you could write it this way. You could put Mrs. Dossie is 62 inches tall, something like that. Okay. Now, I'm trying to give you as many math examples as we can on here. Sometimes at this level, if you go and you were to watch a video on YouTube or something like that, a lot of times they'll give you examples kind of like the one we had up here with the where people live, right? So it'll say, if you live in Dallas, then you live in Texas, and you would say, false, because we said, I think there was a Dallas, Tennessee, something like that. You would then do the converse of that. So you would say, if you live in Texas, then you live in Dallas. Well, that's obviously false. I live in Waco, right? I still live in Texas. So I would just put I live in Waco, or Waco, Texas. You could do that because there are other cities in Texas that are not just Dallas, right? That's not the only one. So just keep in mind, they might be math examples. They might be life examples that they're hoping that you'll know about. And so either of those are fair game. It's just to practice the vocabulary here, the hypothesis, conclusion, converse statements, and then calculating the truth value and giving a counterexample. Okay. Remember that if you have any questions this week, I have office hours just on Tuesday because I won't be here on Thursday, but normally I'll be here Tuesday and Thursday. If you have questions in between that time, you could go ahead and email them to me, and I will try to get back to you before tomorrow's quiz. Don't forget, we have a quiz tomorrow that you also need to study for.